let me close all the other junks. Oof. Okay. Yeah. I'm sorry. Okay, do you want me to start? Okay. All right. Good afternoon, good evening, ladies and gentlemen. I'll be talking about the values of public construction. I had a data set downloaded from data.gov, which shows several values, monetary values spent on constructions. And with these, I was able to calculate the standard deviation as well as the populations, the statistics, that's the Z statistics. I was able to make a claim that based on these data sets, which you can see, if I'm gonna increase the values, this data set shows that constructions do take place. I mean, my null hypothesis was that constructions, sorry, let me see. My H1 states that investment made in transportation infrastructure at a given infrastructures at a given period are more prone to price inflation than any other infrastructures on average. While the alternative hypothesis claims otherwise. So we, based on this, and from that, I was able to calculate my the Z statistics using the mean, the sample mean minus the mu over the standard deviation divided by the square of the total number. So I was able to get a negative value for my Z distribution. What these, I was able to make all these calculations based on the data that was gotten. I think I will have to hand over to my other colleague so he can talk about his findings, as well, his claims, as well as his findings as well. Thank you. Okay. Over to you. Your speaker. Your speaker is off.
No, yeah. Can you stop sharing
Yeah.
your screen?
Okay.
So I'm gonna share my screen.
Yeah.
All right, the share screen. Okay. PowerPoint. Yeah, can you see my screen?
Yes.
All right, so I got a data of the height of American people, and based on that data, I researched the random sample, the measurement of height in the centimeter format, and also calculate the sample mean and the standard deviation. So just to show you my data set, and that is, can you see my data set?
Yes.
All right, so this is the data of male and height of sample height of American people, male and female. So I divided this data here into two format, which is female here and male here. And
I
from
can't
these,
see it again. It's gone.
huh?
It's gone. Your data set is gone.
Oh, okay. So let me get back to my PowerPoint.
Okay.
So for my PowerPoint, so this is the graph of the total male and female data, like the height in centimeter, and here is the frequency. So variable, the total mean is 168.31, and the standard deviation for this is 9.81. So if we separate the male and female, then we will get the like different standard deviation and also different mean for the two different sample, like female and male. And from this analysis, we can say the distribution for each gender has a smaller standard deviation than the single distribution of all adult, which is consistent with the tighter spread around the mean for both men and women in the graph. And also secondly, this result shows how the mean provides more precise estimates when we assess height by gender. In fact, the mean of the entire population doesn't equal the mean of the either subpopulation, which is male and female, and that is misleading, as we can see a different standard deviation for both the data. And from here, we can claim that the average height of male in US is taller than the average height of female. So yeah, thank you all.
Thank you.
Hi, everyone. This is Learning Engagement 6, presented by Olaiwola Olaita. It's about government construction spending on water, October 2019 to February 2020. The data source is from US Census Bureau, construction spending April 1, 2020. These data could be extracted, could be found at the www.census.gov.construction, as can be seen on the screen. This data was extracted from the a larger one. This is just the part that borders on water supply from October 2019 to February 2020. The samples, this is the population, is just a few extracts from the entire data. The average from it is 17.95 in million dollar. The population standard deviation is 389.25. These are the samples obtained, and this is the X bar, the mean, the sample mean. I'm adopting a two-tail hypothesis testing to determine if the average government spending for the 5 months is different from the population mean of 17,953 million. Assume level of significance of 0.05. The hypothesis, the null hypothesis is population mean is equal to 17,953, while the alternate hypothesis is population mean is not equal to 17,953 million. The significance value is between minus 1.76 and 1.76. Graphically, these are, it will look like, these are the rejection points. These are the acceptance points. The additional rule states that if the computed Z value is not between minus 1.76 and 1.76, we then reject the null hypothesis. Otherwise, we accept the null hypothesis if it's between minus 1.76 and 1.76. The Z value is computed as stated above, and the result is minus 0.99. From this, it's obvious that it's in between the range of values for Z, which is minus 1.76 and 1.76. The interpretation of this is that since the value of Z falls between, the range set, which is level of significance, minus 1.76 and 1.76, we therefore reject the null hypothesis. This means that the average spending on water by government for the 5 months period is not different from spending in each month. Thank you.